So today's objective, I can simplify exponential expressions using the multiplication properties of exponents. I can simplify exponential expressions using the multiplication properties of exponents. Let's read it together. 1, 2, 3. I can simplify exponential expressions using the multiplication properties of exponents. So think about those two questions. What concept are we on? Okay, first of all, think about it. What concept are we on and what are we doing with it? So tell your neighbor what concept we're on, please. All right, let's continue. So exponential expressions is our concept, and we are simplifying them. So on our prayer model, we have exponential expressions. Definition for that, we said they are numerical and variable expressions raised to a power greater than 1. Numerical or variable expressions raised to a power greater than 1. Examples: 2 to the third, x to the sixth, negative 3x to the fourth, x squared y cubed. Non-example: we have 2 cubed equals to x, a times b squared equals to 12, and the other one, negative 3 plus x. All right, so our definition says numerical and variable expressions raised to a power greater than 1. Okay, so pens down, eyes up here really quick. So think about this question. Exponential expressions, this is a definition, and these are examples. Numerical and variable expressions raised to a power greater than 1. Look at these first two non-examples, these two right here. Think about the question. Why are these two non-examples? Think about it. Okay, now look at this one right here. Why is this one a non-example? Okay, discuss it with your neighbor. Why are these two non-examples and why is this one a non-example? So critical attributes. Once again, make sure that you write that they are expressions only. Okay, notice these are expressions. These are equations. And the second requirement, that exponent has to be greater than 1. Look at all these. Look at these two right here. This is an expression, but it doesn't have the exponent greater than 1. Okay? Steps. Number 1, identify if the exponential expression is a product of powers, power of power, or power of product. Identify if the exponential expression is a product of power, power of powers, power of products. Identify if the exponential expression is a product of powers, power of power, or power of products. Identify if the exponential expression is a product of power, power of power, or power of products. Step 2, use the appropriate property. Use the appropriate property. And step 3, simplify. Things to circle with red. First step, the word identify. And then you're going to underline all 3 properties that we're looking at today. Product of powers, power of power, and power of products. Step 2, circle use, underline appropriate property. And step 3, simplify. Once again, 3 steps. Identify if the exponential expression is a product of powers, power of power, power of products. Step 2, use the appropriate property. And step 3, simplify. on the left side of your notes, where you write your Q's, I want you to write this down. Things to remember. Things to remember. On the left side, on the left column of your notes, where we write Q's, right? Questions or things to remember. You're going to write in there, 2 is equal to 2. You guys got that? All right. However, from now on, whenever you see a number without an exponent, I need you to write an exponent of 1. So therefore, whenever you see a 2, what are you going to write? 2 to the first, right? Okay. Same thing with variables. Whenever you see a variable such as x, what are you going to write? X to the first power. Let's see. What if you see -5? Okay. -5, and you write the exponent of 1, right? Yeah. Yeah, we'll get there later. But for right now, does everybody understand that? On the number, you're going to write the exponent, yes? I need to clarify, though, there's certain rules that we need to follow in regards to the negative in front of the 5, so we'll get to that in a little bit. But just so that we remember, any number that you see that does not have an exponent, you're going to add an exponent of 1. Are we there? All right. Next thing, I want you to write commutative property of multiplication. We're still on the left side of your notes. Left side of your notes, commutative property of multiplication. Write that down. Skip about 1 line or 2 and write associative property of multiplication. Okay? For the commutative property of multiplication, I want you to write, I'm going to do that in blue, 10 times 2 times 10 times 5. All right? So, commutative and associative. We've already been looking at these properties since 3rd grade when they introduced you to these properties. So, let me just refresh in your memory. Here it goes. If we have commutative property of multiplication, it says that, first of all, what is 10 times 2? Times 10. Here it goes again. 10 times 2 times 10 times 5. Okay. So the commutative property of multiplication says that no matter the order that you multiply these numbers, if there's multiplication throughout, the value or the product doesn't change. So check this out. I'm going to change this 10 here and the 2 here. So it becomes 10 times 10 times 2 times 5. And let's see if the product changes. Let's see. What is 10 times 10? Times 2 times 5? It didn't change. So therefore, that's the commutative property of multiplication. Associative. Associative property of multiplication. Here it goes. Whenever we have commutative property of multiplication, usually right after we can use associative property of multiplication. Who has a little cousin or a brother that they're always following you around? That if they buy you ice cream, guess what? They want ice cream. If you want to play the game, guess what? They want to play the game. Well, the associative property is like that. Check this out. Right after commutative property comes the associative property. So I'm going to write this. 10 times 10 times 2 times 5 equals. And I'm going to use green It's called the associative because if we associate or we group, I'm going to group these two, 10 and 10, and then the 2 times 5. Once again, if there's multiplication throughout, and if we group, bless you, differently, the product doesn't change. What is 10 times 10? 100 times. What is 2 times 5? What is 100 times 10? 1,000. The product didn't change. Okay? So these are the things that we need to remember for this lesson. And I'm going to touch on a couple more, but for right now, that's all we need. Are we there? Okay. So let's go back to our notes side, on the right-hand side where you're taking notes. If you can fit it in there, that's fine. If not, continue on the back. Next, I want you to write the first property that we're going to look at. Product of powers property. Product of powers property. Product of powers property. And to illustrate that property, I'm going to call this example Q. Example Q. Okay, here we go. Write this down, 2 times 2. Okay, pens down. Eyes up here. Writing utensils down. Here it goes. It says, product of powers property. The first thing we know is that 2 can be written which way? 2 to the first, and this one is 2 to the first. The product of powers property says this. If this and this have the same base, if 2 numbers have the same base, therefore, we add the exponents. What is 1 plus 1? 2. Okay, now before you write that down, let's go through our steps. Step 1, identify if the exponential expression is a product of powers, power, products. Right now we're looking at what? Product of powers. What is step 2? Use the appropriate property. Did I use it already? Yes, 1 plus 1 is 2. And what is the last step? Simplify. So what is 2 squared? 2 times 2, which is 4. Copy that, please. So if that's true, check it out. What if I had this? See if you can finish that off, please. So the first thing, who did this? To the first power both. From there you use the property of product of powers, which is 1 plus 1. So who got x squared? Okay? So if this is true, finish this one. 2 times 2 to the third. And of course, whatever I do with numbers, I'm going to do with variables. X times x to the third. Finish those two, please.